Good morning, my name is Javier and I'll be doing problem number 4 for Calculus 3 final review. And the question is, or the problem is, use cylindrical coordinates to find the volume of a cone where z equals h times 1 minus r over r sub o. So the given information we have is that z equals h times 1 minus r sub o. And then they're also giving us h equals 7 and r sub o equals 3. And I'm going to try to draw a picture of our cone. So this is y, x, and then we have straight up, we have our z. So we have, see if this comes out pretty good. And then we have our h. This right here is our r sub o. Okay, so there is a formula that we can use, and just to determine the volume of a cone, which most of us should already know, and it's the volume equals pi 1/3 pi r squared times h. So we have enough information to where we can just plug in our height and our radius and we get our answer. So this problem is actually we're gonna do a triple integral to actually come up with this formula and be able to solve it that way. So the first thing we really have to do is find our bounds, and since we do have z, I'm going to start off with that. So we said z equals h 1 minus r over r sub o. And then another thing we do know, let me put it on here before I forget, is that r equals the square root of x squared plus y squared. So we're going to need that. So the first thing we do, we can just go ahead and distribute the h. So now we have z equals h minus r, or hr over r sub o. And then we can go ahead and plug in what we know for that r. We said that r equals the square root. So now we have square root of x squared plus y squared. So we know that h minus h over r sub o times the square root of x squared plus y squared. So we have that thus far. And then if we go ahead and take this out just to make life simpler on us, we can go ahead and have z equals h r sub o times r sub o minus the square root of x squared plus y squared. And just to kind of make life easier again, I know it kind of seems redundant that we just changed it to r to x squared plus y squared. We're going to go back to r just to make it easier, less numbers, less variables we have to deal with. So we'll do with z equals h r sub o minus r. Now what this is telling us is basically this is our bounds from here to here. So we know that our bounds for this is going to be from 0 to h or r sub o square sorry, not the square root. It's going to be r sub o minus r. So that's one part. We're going to need that. I'm going to put a little star. I'm going to do a different one in a different color because we need 2 more bounds. We're also going to need the bounds from here to here. And that's actually a fairly simple one, because if we you use r as the if we let r be the circular projection of the solid onto the r data plane, we know that this would go from 0 to r sub o, because of r sub o is actually this little part right here as far as it goes. So that's another boundary, so we got to keep that one in mind. And then the last boundary we need is the actual circle, and we know that a circle goes, if it's 360, we know that it's going to go, our data is going to go from 0 to data to 2 pi. So that's our boundaries, and now we can set up our integral in order for us to solve it. So to set up our integral, there's 2 ways we can do it. If we know that this is 4 even parts, so we can avoid going from 0 to 2 pi, and we can just say, hey, let's just use 1/4 of it, or we can multiply all our integral by 4, And we can go ahead and go 4 integral from 0 to pi over 2, not 2 pi. And if you look at it, this is the same thing as going from 0 to 2 pi minus this would be the same thing as 4 integral 0 to 2 pi, or 2 pi over 2. And then our next integral is going to be, we can go right here, our r from 0 to ro. And then our last integral is going to go, it's going to be our first one we solved, our boundaries we solved, which is 0 to h over ro. And we said that was ro minus r. And then we have r dz, dr, d data. So now it's just a matter of integrating with respect to each integral. So the first one we're going to do with respect to dz. So we're going to have 4, 0 to pi over 2, 0 to ro. And then we have, once we integrate, it's going to be rz from 0 to h over ro minus r. And keep in mind we still have our dr, d data. So now we're just going to simply plug in z. So we have 4 integral from 0 to 2 pi, 0 to 0 to ro, and we have r times h over ro minus r, and then the 0, even though that just goes away, keep in mind we still have to carry our dr, d data. So once we kind of reduce this a little bit, this is really a constant, so we can go ahead and pull it out. And we're going to distribute the r at the same time, so we're going to have 4h is volume. 4h over ro integral of from 0 to 2 pi over 2, 0 to ro, and then we have ro r minus r squared integrating with respect to dr, d data. So now we're just going to integrate with respect to dr. So let's see, we can integrate that, so we're going to integrate our r. So we're going to have 4h over ro pi over 2, and we're doing this integral right now, so that's going to go away. So now we're going to have ro r squared divided by 2, because remember we're going to go up 1, we're going to divide by 1, we're going to go to the exponent is going to be added 1, we're going to divide by that same number, minus r to the third divided by 3, and that's going from 0 to ro d data. Now to make my easier, I'm going to get me a common denominator that would just kind of be able to reduce this stuff a lot easier. So we're going to have 4h over ro, the integral of 0 to pi over 2, and this is going to be 3 ro r squared minus 2r, let's see, yeah, r cubed divided by, everything's going to be divided by 6, and then still from ro to 0. So now I'm just going to plug in. I know it's a lot of steps. Sorry, I like to show all the work so there's no questions. Alright, 4h over ro integral to pi over 2, 0. So we're going to have 3 ro squared minus 2ro cubed minus 0, and this is over 6. So if you think about it, this right here goes to ro cubed, so that just goes down to, that goes away, and once subtract that goes away, so our new integral is going to be 4h over ro, the integral of pi over 2, from 0 to pi over 2 of ro cubed over 6 d data. So we got one last integral to do, and this is 0. So we're going to go to, I'm going to see if I can fit it in here. And it's going to be 4h over ro, and once we integrate it, it's going to be ro 3 over 6, and we have data, and that's going from 0 to pi over 2. So now it's just as simple as plugging in our pi over 2 and our 0, and we should get close to our answer. 4 pi over RO. Well, as a matter of fact, we can make it easier. We can reduce this. That'll cancel. That'll bring us down to 2. So we have 4h RO squared. And then we have our data, which is pi over 2. Right? And then all this. Yeah, pi over 2 is divided by 6. So this cancels with that. That leaves me 2. That cancels. That gives me 3. That cancels with that. So now we come down to pi RO squared h divided by 3. So if you look at this, this is the formula that we all know from lower math classes. We kind of just proved that finding the volume of a cone is done this way. Look at the volume is 1/3 pi r squared h, so which is what we got. So now the only thing left is to put in our h and our radius, which was initially given to us. So now we have pi, our RO was 3 squared, and our h was 7. Divide all that by 3, so that goes away, this goes away, so now we actually come out to 21 pi. So just to check your answer, if you do all the steps, it took us like 10 minutes to do this problem, but we do all the steps, and you know the formula to find the volume of a cone. It's as simple as just plugging in the information that's given. And if you do that, so we get 1/3 pi, that's an ugly pi, and then the height was, or where's it, r squared was 3, so it's going to be 9, and 7. If you look at that, this 3, it also comes out to 21 pi. So you see, that's just an easier way to just check your answer and make sure you got the correct answer. Alright, thank you for your time.